We had two questions for homework last night, both involving electrostatic forces, Coulomb's law forces, but in two dimensions. We know that every time we see a question, we've got to think about all kinds of different things. One of the things that we've got to think about every time we see a question now is the dimensions. Is it one dimension? Is it two dimensions? If it's one dimension, problem's easier. If it's two dimensions, we have to do X and Y. We can't just add things together the old-fashioned grade 1 way. 3 plus 4 is equal to 7. Okay? When we're adding vectors, 3 plus 4 might be equal to 5. And we've got to pay attention to that. We've got to be aware of that, breaking it down into X and Y components. We're going to do question number 2 here, and we're going to break it down into X and Y components to show you how to do that. So let's calculate the net electrostatic force on charge B, shown in the figure below. All right. First of all, okay, the very first thing I'm going to spot here, okay, electrostatic force, it's a Coulomb's law problem, right? We know it's going to be a Coulomb's law problem. Okay, I want to think about my red pen. Lots of things to circle here in the red pen as well. I got microcoulombs, I got negative, I got centimeters, I got microcoulombs, centimeters, microcoulombs, negative. Talk about running out of the red pen, running out of red ink here. Okay, there's a lot to circle there, but there's a lot of places in this question that can lead to a silly mistake. We want to avoid that, right? Draw attention to those things. What else do we got? Well, we want to find the force on B. Let's find the direction of all the forces on B. A and B are oppositely charged, so B is going to be attracted to A. We'll call that FAB. And B and C are also attracted to each other because they're opposite. B is going to be pulled down towards C. We'll call that FCB. Wait, it's two dimensions. Okay, I've got an X and a Y, so it's two dimensions. I can't just get the values of both of those forces and then add them together the old-fashioned grade 1 way. 3 plus 4 is equal to 7. Okay, in this case, 3 plus 4 wouldn't be equal to 7. All right, let's get those forces, the magnitudes of those forces. The FAB force, KQA/QB over R squared. Don't forget to make QA 2 times 10 to the minus 6 coulombs. 10 to the minus 6 because it's microcoulombs. QB is 1 times 10 to the minus 6. Notice I dropped the sign for the 2. I don't care, it's negative. Okay, that was important for determining the direction of the force, but it's not important in determining, in putting it into the equation. R is 0.01 meters. If you have trouble converting centimeters to meters, moving the decimal place over, that seems like a silly thing, right? Seems like a silly thing. Converting 1 centimeter to meters, how hard could that possibly be? Right? That's the easiest thing in the world. You know what? That's one of my weaknesses. It is. When I go to move the decimal place over, I often mess up on little things like that. So you know what I do? I do one of a couple of things often. I say 1, I know the conversion factor is 100, put it on your calculator. 1 divided by 100 is 0.01. Your calculator moves it for you. Okay, the other thing that I'll sometimes do is say, look, 1 centimeter, okay, it says on my data sheet that a centimeter is 10 to the minus 2. Instead of making it 0.01 meters, I'll just say it's 1 centimeter times 10 to the minus 2 meters. Hey, it looks a little uglier, but it's correct, and I don't have to worry about moving the decimal place over that. Does that make sense? I don't care which way you do it, as long as you can do it correctly. What do we get for the value of that FAB? Yep. 179.8 newtons, thank you. We should want to go probably 3 or 4 decimal places. Do you have 3 or 4 there? Okay, is that exactly? Okay, so if it's exactly 179.8, then obviously you don't have to put a 000 after it, obviously. FCB, same kind of idea here. This is going to be 8.99 times 10 to the 9 times, what's QC? 2 times 10 to the minus 6 times 1 times 10. Oh, look at that. It's the same numbers, isn't it? It's exactly the same numbers, right? What are we going to get for that one? How about 179.8 newtons? Okay, what do we got to do to actually find the force here? Okay, remember, it's 2 dimensions. We got to ask ourselves that every time now. Is it 1 dimension? Is it 2 dimensions? It's 2. So we can't just say 179 or 180, let's say, plus 180 is 360. It isn't. Okay, we've got to add this vectorially, where we say 179.8, 179.8, and then the resultant vector is right there. The angle, well, we don't even have to do a calculation for the angle. What's the angle? 45 degrees, right? If both sides are the same, it's got to be 45 degrees. Although you could do the tan function, the inverse tan function to figure that out. What's the value of the hypotenuse there using the Pythagorean theorem? Yep. 2.54 times 10 to the 2. Oh, I guess the answer's there, isn't it? 2.54 times 10 to the 2 newtons. Good? All right, quick little question for you. We haven't seen one like this, and honestly, I wouldn't anticipate you will. I wouldn't anticipate you will see one like this. But what if you were asked to find the net force not on B, but on C? How would you tackle this question? What would you do when you saw that question, besides maybe cry a little bit? What would you do if you were asked to find the net force on C? Why should it be harder? Well, you know what? It is a little harder. But you would absolutely be equipped to handle that question. I don't think you'll have to. I don't think you'll have to, because it's quite a bit of work. And I think it's too much work for a multiple choice question. But let's address it just in case. What would you do? What do we always do when we see a question? What's one of the things? Okay, even before that, even before we solve for anything, before we look at givens, before we solve for anything, what? Draw a free body diagram, sure, even before we do that though. Okay, those little things, right? Still circle things, right? Still do the red pen stuff. I'm going to erase those right now just so it's not so cluttered, but that's what we'd do if we were actually solving this, right? Completely. Okay, we'd also identify that it's a Coulomb's law problem. We'd also identify that we've got to draw a free body diagram, and we'd see when we draw a free body diagram that it's 2 dimensions. We'd have a force this way, we call that FAC, and we'd have a force this way, we'd call that FBC, right? B is pulling C upwards, and A is pushing C downwards, right? Make sense? This is a 2-dimensional problem, right? What's the problem with this? What makes this harder than the last question? What's different about this question than the last question? We got a funny angle, right? And what do we say when we see a funny angle? We don't like funny angles. We haven't seen a funny angle this unit, have we? But we know how to deal with them. We don't like funny angles. Here's what you'd have to do, and somebody alluded to this before. Might have been you, I'm not sure. We got to find out how far that is, right, between A and C. So we do the Pythagorean theorem right here, 1 squared plus 1 squared, square root it. I think that would be 1.41 centimeters. I think it works out to be, using the Pythagorean theorem. We'd also have to get the angle right here. Okay, the angle right there by using a trig function. That would correspond to the angle right there as well. Be the same one, right? Okay. Once we have the angle, what do? Joseph said, I don't like funny angles. We'd take it over here off to the side. We got our angle of, it'd be 45 actually, wouldn't it? In this case. We'd have our value of FAC. We get our x and our y component of it. And then we break it up into x's and y's, right? So we've got a y component for this one. And we'd have an x and a y for this one. Get the total x, get the total y. And then we would say, and then we would add them up. But not add them up like this plus this plus this, the old way, the old grade 1 way of adding. Rather, it would be the total x the total y, get the hypotenuse. Does that make sense?